The blown film process is so named because it is just like blowing a soap bubble. Air is blown inside a ring known as a die of molten polyethylene to create an inflated bubble. Air is blown on the outside from what is called an air ring to both stabilize the bubble and remove the heat from extrusion. Plastic is expanding between the die and the frost line, or the point where the melt crystallizes into solid form. During this transition, the molecules are orienting in both the long or machine direction and the cross or transverse direction. The relationship between the solidified size and the die diameter is called blow-up ratio. Blow-up ratio has a strong influence on blown film properties. A low blow-up ratio is like a stovepipe, with the molecules aligned mostly in the machine direction. If the molecules are all oriented in the machine direction, the film will be strong in the machine direction. This is the direction it came out of the die. The trade-off is that the film will be very weak in the opposite transverse direction. It will be prone to splitting like this. Blown film lines are made in different scales to make a variety of widths of lay-flat tubing. All blown film starts out as lay-flat tubing. The large rolls you see here will be printed and slit into 3-inch wide yellow caution tape. After the order is set up, the process is fairly steady and continuous. Starting an order from scratch involves both time and scrap. Every pound of scrap you see here costs about $1, which usually cannot be reclaimed. Rational manufacturing minimum order quantities, or MOQs for short, are dictated by the scale of the blown film extrusion line. The wider the film width, the higher the MOQ. A properly tailored plastic film is a combination of raw material selection and extrusion conditions. Consistent continuity of PE film supply requires attention to using the same materials and extrusion conditions every time.